Welcome to the FUSE project. I'm Steve Gorelick at Stanford University in California and the project leader. FUSE stands for Food, Water, Energy for Urban Sustainable Environments. Our consortium consists of 4 teams: Stanford in the US, UFC in Germany, OFSI in Austria, and YASA also in Austria. We thank our sponsors, including the Belmont Forum SUGI Initiative and our respective funding agencies. We are an international interdisciplinary team that studies water resources, agriculture and food security, energy, computer simulation, facilitation and stakeholder engagement, urban sociology, economics, and complex systems modeling and integration. Our goal is to produce solutions to urban food, water, energy challenges through participatory model building. We have 2 study areas: Amman, Jordan, and Pune, India. Both are cities of about the same size, with 4 and 7 million people respectively, with population that is expected to double by about 2050. Both cities have intermittent freshwater supplies. We follow a 3-step procedure. First, we get stakeholders' ideas and local expert solutions to future food, water, energy challenges. Next, we develop a policy evaluation model incorporating all the ideas obtained through participatory model building. Third, we get stakeholder responses to policy evaluation results. We've accomplished the first stage already with 6 workshops led by OFSI, involving a total of approximately 200 stakeholders and experts in India and Jordan. The stakeholder workshop in India is where we collected ideas for future food, water, energy challenges. It was a 1-day symposium. The stakeholders were interviewed and selected from NGOs, farmers, industry representatives, and civil society. The challenges that they came up with involved limitations on resource access, power outages, lack of regulation of groundwater, particularly in the city, and concerns about impacts of urban sprawl. A similarly structured workshop in Amman occurred in March of 2019, a month afterwards, and it indicated the challenges revolved mostly around water, as Jordan is such a water-scarce region, and it also involved concerns over energy prices and agricultural production limitations. The next day of each of those 2 meetings, we had a workshop involving experts. They were government representatives, past government officials, academics, and other experts and consultants who provided ideas for potential solutions. In Pune, the ideas they came up with for solutions involved water transfers, rainwater harvesting, changing sugar production price supports or subsidies to consumers, and enhanced biofuel production based on sugar conversion to ethanol. In Amman, policy interventions focused more heavily on obtaining water supplies from seawater desalination by stopping water theft and reducing water losses, averaging about 50% in the country, and considering extensive solar farming. The next step was for their team to develop a policy evaluation model incorporating all of the ideas, and that's what we're working on currently. This involves development of a systems model, and I'll step you through it. The systems model starts with biophysical modules. These represent rainfall runoff processes to get stream flow, groundwater response to recharge and pumping to get groundwater levels, and agricultural module to determine crop yields. Next, we have human modules, and the human modules represent human behavior, water agency decisions on water allocation, cities' demand for water, and farmers' decision for crop selection. Next, we track all of the flows. For water, as shown here, we track water flow from one potential module to another potential module where water can flow. Next, we have decision making, and that's charted out. So we have decisions made by the human modules involving transfers and water diversions and withdrawals, and even the farmer's choice of which crops to plant. Next, we have scenarios. It's impossible for us to know what's going to happen in the future, so we treat this as a scenario. We have scenarios for climate change. We have scenarios for population growth. We have these scenarios for energy prices and so forth. So there's certain things that we don't know that we have to just treat as possibilities in the future and look at various possibilities. Next, we have interventions. So what are the solutions that might achieve greater sustainability of the food, water, energy system? You could have solar farming. You could have regulations by the institutions that control water. You can have tariffs, you could have subsidies, you could have enforcement reallocation. You could have new supply wells, you could have new infrastructure. So all of those interventions are possible. You put this together and you get this entire mess. Our real model is far more complex than this, but the idea is that we can track all the flows, we can track the decision-making processes, we can route them through our best understanding of behavioral modules, which are largely economic, and we can look at the physically based modules, which are simulation models. We combine scenarios, things that we really can't know in the future without testing them over a broad range of possibilities, and interventions. We combine the scenarios and interventions to get narratives. The next step is to get the stakeholders' responses to these policy evaluation results. And that's our plan. If you want to know more about this, please come to the FUSE website. We have many publications and presentations listed, and also explains what we're doing, various reports on our workshops. Please come and take a look. If you want to communicate with any members of our team, the various teams are shown here. They're also listed on our website, and you can contact them as you like. Thank you for your time.